Okay, so you have a data frame. You know, these sub-IDs are different, but you may have different rules with all the same, because the same person, data on the same person. What I'm saying is that we want to be able to select, let's say, the data on employee 1. If you move on, we'll get to, let's say, the data for employee what? 19. And so forth. What do you think we should do? So that at the end of the day, we have a new data frame made up of, let's say, employee 1, employee 19, employee 25, employee 1020, and so forth. Okay. So you should practice around this. I'll ask you later on. I can give you a sample data to do it, but from what I have illustrated, you can create your own data frame with different IDs, right? Okay, and then you what I want you to do is to be able to, extract a sub data frame from it, but of course must contain different IDs. Okay. Remember, in this case, the IDs, some of them are repeated. Okay, all right. Okay, so now let's move on. And so last week, we were able, I think we were talking about functions. We were able to modify our own functions. Yeah. Yes. I will send to you. If you want, you can create your own. I'll get you a dummy version of it. But from what I have done, you can easily create a data frame on your own. Okay. Today is our 20th, right? Please take attendance. So last week, let me go back. We did functions. Okay, so it was tutorial, right? Okay, so now we know how to generate observations from, so please, I want you to generate your own, generate a set of observations from a gamma distribution. I want you to generate observations from a gamma distribution. With parameters two and 5. So generate 100 observations from a gamma distribution with parameters. Did you get access to the SOA data? I sent it to one of your colleagues. Yeah. Because the site has been deleted from. Pardon me? You should check it online. You couldn't get it. Just put the title in Google. You'll be able to. If you are connected to internet. If you're outside campus, they will ask you to pay. But Taylor and Francis, University of Ghana. That's a cheaper idea. But the site for the data has been deleted. So I gave the site from GitHub that I've uploaded the data on it. That we should be able to. So I'll give you tomorrow, you should submit that assignment. Is that okay? Tomorrow you should submit that assignment. The data is I get all my things. The link. And let's see how it looks like. The next thing we are going to do is to be able to estimate the parameters of these distributions. Did you do that? How we do it? We haven't. So let's do it. But you can generate observations from the gamma distribution because we've done generating observations from the distribution. We did one from normal and so forth. So now we have gamma. So what do you have to do in order to get the gamma distribution? So you do question mark R gamma. When you finish, I'm going to let you find the probability. You know how to move. So go to the R and go to R. Please, hurry up, hurry up. Our gamma. You are done with that. So generate the observations. The shape is 2. The scale is what? 5. So generate the observations. You have done that one. Then do a histogram of it. Not a histogram. And describe to me what the histogram of that data. Do you have to? Yeah, you can take it off. The rate is 1 over the scale, right? So you can take it off. So by default, it will calculate it by itself. Please, then a histogram of it. What's your histogram? And we are naming this histogram as that is a simulated plane, right? So S dot plane. So histogram has to be able to So first of all, you generate 100 of the bases from the gamma distribution to parameter 2. S dot plane. I did not see title. I said it should be labeled S dot plane. So let's say label the claim size rather. So the data is like a simulated claim size. So please name it. I will come and check out.
It's a histogram.
Yeah, the histogram. So your data is claim size. Yes, and your histogram must be labeled as such so that you can use it. You can use 1,000 or 100. Label your histogram. Or the data is claim size. So your histogram must reflect that. So you plot your data in R, you copy this graph into Word, you name it, I'll come around to check. In other words, provide figures so and so with yeah, maybe figure 1. And then write write your ID numbers so that, because I've seen that some of you don't listen. So write your ID number. If you were working in a group, write it. So, unfortunately, I did not record, but so yeah, and this you can. We should start again. Which one? This one? No, that one is all part of art. Oh, as I said, you will get even a better presentation on YouTube. Okay, just when you go to YouTube, just. Let me, I think that will be better. I don't want to waste our time on this. So, let's say even thesis. Okay. Okay, so let's assume we come here. Okay. So you are not interested in whatever is going on, just you know how to do it. So how to make chapters is there. How to make table captions. That's what I did earlier. Is that okay? How to even references you can. You know, referencing, you don't have to finish your work. Then now you are looking for reference number, whatever. That's what some of your colleagues are doing. They finish their work, they are now looking for reference. You won't find it because it's a Kweku 2020. You're now going to search through the internet for Kweku. So as soon as you start with your literature review, you are getting your references done, right? And so forth. So all this, it's common on YouTube. So how to get tables, right? Fit table into Word document and be able to reference it. That's what I demonstrated with figures. Okay, so please just let's be proactive in some of these things. Okay. Can I move on? Okay, just maybe thesis or report. Maybe how to write a report with Word. You can search for that as well. Okay. You will get it. So what we did, creating report template in Word document with table of content. It's not that difficult at all. Okay. Any question? Can I move on? Good. Okay. So I hope you have sent in your result. But basically, these are the things I want you to note, that it is important that when you write your report, you have headings, you have subheadings. You cannot get introduction, then you have only one session. Okay, so if I'm going to divide it, then there must be a 3.2. Otherwise, there's no need. Right? Okay, so I cannot be dividing a session into one session. Then there's no division whatsoever. Is everybody okay with it? Yeah, so if I have 3.2 alone, I cannot have 3.2.1. If I'm going to get 3.2.1, then there must be 3.2.2. Okay, so this, if we were to do this, this will be heading what? Heading 3. And so for them we move on like that. So please take note of all this. And how to label no heading over there. Right? Okay. graph must be named, and you can only do so in now before you import. Is that okay? Or export and put it in now. Okay. Any question on this? Okay, let's move on. So now everybody understands this. Now let's do a bit of probability. Now, in my case, let's say I want to take reinsurance at claim sizes over 30,000, assuming this is in thousands. Then if a claim comes and it is over 30,000, the difference will be paid by a reinsurance company. Okay, so in this graph, I want to be able to get a red line to show, to present it at a board meeting that, okay, any claim over this will refer to the, how should I do it? In other words, I want to get a vertical line here. Who can help us? AB line, good. So superimpose a vertical line. Okay, so here I'm going to use, your graph will be different from mine because we simulated observation. So look at yours and choose a point and do this. So AB line, what should I do? This is what? So you can look at the health files for AB line. So this, if you don't know, you go to Google, the same way you use it for your assignment. Okay? How do you superimpose a line on a graph in R? You'll get it. So AB line, you can now search. H is for what? Y values for horizontal line. V is for what? S values for what? Vertical line. Which one do we want? A V. Good. So V, in my case, is equal to what? 30. Then I need a color, which is red. I can even get line width, maybe 2, so that it will be big enough. Okay. I don't have time to be doing this. I can go and plot that and give a test over here to show that this is what? Reinsurance claims, and then this one is not reinsured. Okay, so we are the company. You tell your manager or your next supervisor that this is it. Any claims over here. So in this year, we got these claims that were referred to the reinsurance company. This one was not done. So in your graph, you can do this. Please, it is important that these are the things you will need when you go out. Especially a plot, because that's what you can use to what? Demonstrate reports. So please make sure that you are very conversant with some of this. When you go and do your service, they give you and they will retain you. But if you go and they give you and you can't even do anything, the next year they are looking for another service personnel. Okay, so you need to train yourself. You don't wait till when you are outside. So all the things that I'm forcing you to do is in your own interest. If I leave you, I say it after today. That's it. Okay. So please make sure you can do a test over here, right? What can you use? You can write over here and write over here to demonstrate. Check, I think M test also. And so forth. We don't have time to be doing this. So let's move on. Okay, so now we want to find the probability, okay, that our graph, we want to find the exceedance probability here. What should we do? please, let's concentrate here. We want to find, let's say, the proportion of those. That's the probability. So later on, now I'm going to let you find the proportion. The next thing I'm going to do is to now do estimation of the parameters. When we estimate the parameters, you can actually find the proportion from the estimated gamma distribution. Okay, and then we check how well they estimate the tails. And then we can even talk about other distributions and so forth. So how can I find the proportion of claims that were greater than 30,000? Yes. You have chosen your own point. So whatever we do, you can what? Do it at on yours as well. How can I find? So this is an exceedance probability or survival probability. Okay. Is everybody okay with this? Okay. Well, if it is, it must be strictly if I want to put it that way. Okay. Exceedance. Okay. Now, then you can also get what? The cumulative distribution. So the cumulative distribution function, okay, the CDF value will now be what? 1 minus what? The exceedance probability, right? Because together they should give us what? 1, isn't it? Yeah. And I can put this in, of course, we know that we'll get what? 0.98. Oh, sorry. What was this? Oh, okay. Who can tell me what is happening? Who can tell me what is happening? Let's see whether people are. Yeah, exactly. So the exceedance probability is in percentage, and then I'm subtracting the percentage from 1. Yeah, so that's what I'm getting there. So actually, if we want to do it, this should be 100, right? Is that okay? Yeah, okay. So we may want to go back and take this out. Okay. Then if we rerun it, we will get 0.98 like that. Okay. So please, you have to be very attentive to programming. Other than that, you mess up. Okay. So, and it's good when you are doing this because it lets you really understand most of the things you were doing from basic principles. Okay. So that's it. Let me see. I have only some few, but it's good we are doing this as well. So I won't say we are wasting our time. Or to some people we are. Okay, what else can I do? Let me just... Okay. So methods of estimation. Okay. Now, remember that 1, in 333, you talked about method of moments, right? Okay. Now, so if I have a normal distribution, okay, or exponential distribution, I can find the method of moment estimator for it, right? Okay. So for the normal, what are the method of moments estimators for a normal distribution? How do I estimate the mean in the normal distribution if I want to use moments? Pardon me? So you use the sample mean. What about the variance? Sample, which one? Okay, so what do we divide the sum of square deviations with? N or N minus 1? Okay. So is that okay? Okay. So if I have, let's say, method of moments, and then I talk about the normal distribution. Okay. Then I can say that I can write a function to give me the method of moments estimate for the normal distribution. So how do I do this? I'll write a function. That function should take in what? The data, right? X. Is that okay? All right. So the estimators are simple. I need the mean, X, and then the standard, well, maybe var, X. This should give me the, maybe I want to name them, so I'll rather open a bracket and end it. So mom is C, so and so, and then I can name it. Names of the estimators will then be what? C. I have the mean, and then I have what? Variance. Is that okay? Then what do? I return mom like this. Okay. So I can do this. So that's the method of moment estimator for the normal distribution. Oh, let me say mom norm, right? It will be better. So that we know that it's for the normal distribution. Okay. So let us generate observations from a normal distribution. So sample norm. Okay. So our norm. So maybe n. N is, let's say 10. Then we have what? Mean or mean? Is it mean or mean? Let's say SD1. Let's see. Why am I getting this? Should be mean, right? Okay. There. Okay. So I can get the moment estimate for this. What is my data? So I use the. Now, this is my theoretical value for the mean. This is my theoretical value for what? Standard deviation. Then I use this to generate observation. I want to now find what's going on? Okay, let's see. It says what? Let me see. Okay. I'm passing the function within the function. Sorry. Okay. Object mom not found. Why is it so? Yes. Which is this? So let's see. There's double what? Double. Okay, yeah, good. Thank you. Yeah, so that's it. So please take note of this. We generated 10 observations from the normal distribution, and then we use the method of moment estimator to estimate the parameters. So the parameters are what? 2 and what? 1. We use the method of moment estimate, and this is 2.4 and 1.0. So that's at the sample estimate. Okay. Now I'm going to increase the sample size to, let's say, 1,000. And I'm going to repeat the same experiment. What do you see? Let me now increase it to even more, 10,000. What is happening? What is happening? As the sample size increases, what do you notice? The sample mean is approaching what? The population mean. What about the variance? The same. And this is what principle? Law of large numbers. So what you were doing in 333, that's what we are demonstrating here. Is everybody okay with this? Okay. So I can now go and write a function for the maximum likelihood and so forth. So this is what we mean by method of moments. Now, for the gamma distribution that you did, when you go home, write the function for the mean, for the variance, as you did in 333. Okay? Now, we don't have time, so let me quickly touch on the maximum likelihood, and then when you go home, you do that as well. Okay. So, 2. Please, any question on this? So that's how you do method of moment. Method of moment usually, because it's easy to use, most packages will not have it, because you can easily write a function to do so on your own. Okay. So maximum likelihood. Please, if you have a question, please ask. Did I stop this? Okay, no, it's running. Maximum likelihood. So 2, maximum likelihood. Now there are 2 ways. We have inbuilt ML or user defined. Okay. When we are lucky, some packages contain maximum likelihood estimation routines. Okay. But later on, as you move up the academic calendar, you realize that when there's a new distribution, you need to write your own function to do some of these likelihood. Okay. So the first one is inbuilt. So we can look at fit this. Okay, we need to go to the mass package. So inbuilt. Yeah. So inbuilt one, we can get some from packages. Example, mass. There's also, I think, fit this R. So let me first get mass uploaded. So fit. Okay. So you see, fit this R. It says what? Maximum likelihood what? Fitting for what? Univariate distributions. So for you to be able to get access to this, you need library mass, or you need to what? Take library mass. Is that okay? So you need mass. Okay. So that's one. There's also a package called fit this R, something like that. I think I should have it, but you need to install it. Fit this. Oh, fit. Yes, so this one. Fit this R plus. So please install that. That also gives you even a standard version of the function in fit this R package, in the mass package. So install fit this R plus, okay, package for, yes. So you need also the fit this R is a function in mass. But if you need additional one, because that, let me go to this one and show you so that you actually understand what I'm saying. So the fit this R. Okay. So it says that maximum likelihood fitting of all univariate distributions. Okay. So So first of all, this function, its usage is of this form. It tells you that it is in what? The mass package. But if you come here, these are the distributions that you can use it to fit. We have the beta, we have the Cauchy, we have the normal, log normal, what have you. Okay. So, if I, for example, want to fit a normal distribution, all I need to do is to, there's no normal distribution. Oh yeah, there's normal. So, I come here, I give it a normal distribution. X is my data. What was our data? I can go back here and it's all sum.norm, right? And then I bring it here. Start, I can just ignore it. It will just use the, we can give it a starting value or not. So there it is. So he gave us, these are the maximum likelihood estimates with the standard errors associated with it. So the mean is 1.998. Do you remember what we did for the moment? So here, you see there's a slight difference between what? The mean is almost the same, right? Okay, but there is a slight difference between the variances. Okay, because the maximum likelihood estimate for the normal distribution, the variance is what? You have to go back to 333. That's 1 over n, isn't it? Yeah. So there is some sort of difference between them. Is everybody okay with this? The mean is the same. Whether you use maximum likelihood or moment, the estimate is just the sample mean. But the variance, the moment is x is 1 over n minus 1. The maximum likelihood is 1 over n. That's why we are finding some sort of difference between it. Okay. Any question on this? So that's how we do the maximum likelihood estimate. If I want to fit this data with the exponential distribution or log normal, I need to apply log norm here. Then I fit it. And what is happening is that we got error. And you should know that the log normal distribution does not take, you are taking log of it. So if you have negative numbers, it won't. Okay. If I really want to do this, I have to find the absolute value. And in that case, you distort even the distribution. You distort the distribution because all the positive ones, negative ones will now be transformed into the other side. So they to distort the distribution. But this can only work if we have something like this. And then you get it. So, I mean, these are the things that let you really understand those concepts you were doing previously. Yes. That's the standard error of the estimate. Yeah, or the estimator, if I should put it that way. Okay. So, that's maximum likelihood. Okay. We can also generate observations. Okay, you generated observation for the claims, right? You remember we did, let's go back. Yes. It's time. Okay. So when you go home, you remember this function, the exponential QQ. We can now look at it for my claims data. Was it? I thought we should be getting all the. Okay, it's fine. But I needed to divide it into two parts so that I have the MF row. Okay, so this the quantile plot for my using exponential, using what? Pareto. Now you should be able to use maximum likelihood to fit your data. Okay, get the parameters, the estimates of the parameters, and then you can now do your quantile plots on your own. And so forth. Okay. So please try the method of moment for the gamma, for the exponential distribution. You can also do so for the log normal, and so for by the time you come tomorrow, you should know that. So tomorrow I will. Now, just before you go, you know the P, let's say if I have P norm, that is for the CDF, right, of the normal distribution, maybe normal. If I have P gamma, that will be all. The CDF of all the gamma distribution. Which means, if I use maximum likelihood or method of moment to estimate this, I should be able to get the CDF, the density, and so forth. If I get the density, I should be able to get my histogram, relative frequency histogram, put in the estimate from either method of moment or maximum likelihood, generate the densities, and fit it over here, and then check which one fits it for. So that's one way compared to the gamma. The quantile. So please, that's the exercise I'll let you do tomorrow, just like you did today. So by the time you come tomorrow, you should be able to do method of moment, maximum likelihood, like we have done, using the packages, either fit this R or the fit this R function in mass. When you finish, you should be able to use this P and D norm to compute your density or the CDF. If I compute the density, I should be able to superimpose it on the histogram of the data. But before you do that, this must be relative frequency. So the claim data you did, when you go, we simulated it from the gamma. You must fit a gamma distribution using the method of moment, and then also what? Maximum likelihood, like we have done for the fit this. Then collect the estimate, put it in the gamma, D gamma, fit it over here, and you can also get the P norm and even the quantile norm. So the quantile one will be on K. So maybe K gamma. And then you put in the values. That also generates, that's what we are using for this. So that's what you can get. Let's say if you are doing the gamma distribution will be here, and the other statistics. Okay. So basically that's what you were doing in 333. Okay, so I'll meet you tomorrow for your exercise. Okay, so I'm going to send you a video on it which will help you. Yes. Which one? The histogram, please print it down there and bring it. Okay? What you did today, print it and bring it. Tomorrow, what you submitted today, bring it now. You go and do it, but you must submit it today. Is that okay? So I'll put a box in front of my office. Make sure that we will find it on your Sakai page. So here you only learn when there's pressure on you. Okay, if I leave you, you won't. So I'm going to post a link to a video on this on Sakai. Okay. Yes. Okay, please make sure you watch this before you come to class tomorrow. Yes. Group one. Yeah, how you submitted. Yes. Which one? No. It's just class. It's just class. So if you did not submit it, that's it. Before. I'm coming. Let me finish. Yes. Hey, I don't want to hear this. No. After the extension. Oh. So next time you do it when you print it. Print it and bring it. All right. So please check Sakai and get that I've posted an announcement with a link to YouTube. Please do so tomorrow before you come to class tomorrow. I'm going to check if we'll get a place at UGCS. I'll meet you there. No. People don't want to learn. Oh, have I stopped the video? I should upload the video.